using op-amp. The subtractor circuit using op-amp is a combination of inverting and non-inverting amplifier. So let us draw the circuit. Two inputs V1 and V2. This is resistance R1. This is also resistance R1. This is RF and this is resistance RF. We know that this is pin number 2, this is pin number 3, this is pin number 6, and there are two supplies plus VCC at pin number 7 and minus VCC at pin number 4. The output is measured at pin number 6. So this is the output. The expected output of this circuit is K times the difference between input signals V2 minus V1. So the first step will be to do the analysis and come to this output equation. To do the analysis, we will be using superposition theorem. So when superposition theorem is used, the output equation becomes output due to input 1 plus output due to input 2. Let this be equation 1. Let us consider our circuit and see the effect when only V1 is acting using superposition theorem. So the first is when V1 is acting. That means V2 is equal to 0. If we redraw this circuit, we see that it is an inverting amplifier. So negative over here, positive terminal is grounded. Resistance R1, RF, V1. This is output 1 due to input 1. So this is an inverting amplifier and we know that output of inverting amplifier is minus RF by R1 into V1. So let this be equation 2. Now when only V2 is acting. So second condition is when V2 is acting, that means V1 is equal to 0. So let us draw the circuit and see it behaves as a which type of amplifier. So when V1 is grounded, so resistance R1 connected to ground, RF connect it as a feedback to output. This is output VO2 and the resistance is R1 and over here RF. And this is V1. Let the voltage at the non-inverting terminal over here be VB. So we know that this is nothing but a non-inverting amplifier. So output of non-inverting amplifier is given as 1 plus RF by R1 into the voltage at the non-inverting terminal, which is VB. Now we need to find out the value of VB. By using voltage divider rule, by using voltage divider rule, VB is equal to RF upon R1 plus RF into V2. Substitute that in equation of VO2. So substitute the value of VB in equation VO2. So the answer comes out to be VO2 is equal to R1 plus RF upon R1 into RF upon R1 plus RF into V2. So this term gets cancelled and the final value of VO2 is RF upon R1 into V2. Let this be equation 3. Substituting equation 3 and 2 in 1, we get the final output as RF by R1 into V2 minus V1. So it is behaving as a subtractor circuit with an amplification factor of RF by R1. So K, the amplification factor K is equal to RF by R1. In this way, op-amp behaves as a subtractor circuit. Now practically, we have to see this implementation. So for practical purpose, let us assume that, let us assume RF is equal to 10 kilo ohms and R1 is equal to 1 kilo ohms. Therefore, the amplification factor K is equal to 10. Therefore, output equation is 10 times the value of V2 minus V1. Now we will be taking two sets of readings. For first set of reading, let V1 is equal to 4 volts and V2 is equal to 2 volts. Therefore, output theoretically should be equal to 10 times 2 minus 4, which is minus 20 volts. The second set of reading, we will be taking it as let V1 is equal to 2 volts and V2 is equal to 1 volts. Therefore, output theoretically will be equal to 10 times 1 minus 2, which is equal to minus 10 volts. So we have to implement this circuit, your subtractor circuit, on the breadboard and have to check whether you are getting the same values as theoretical and practical. So redrawing the circuit over here, which we have to implement negative, positive, R1, RF, RF connected to ground and R1, V1, V2, R1, R1, RF, RF, and this is the output. Pin number 2, 3, 6 plus VCC, that is 15 volts over here at pin number 7, and minus VCC, that is 15 volts at pin number 4. So this circuit we have to implement. While implementing, if you see over here, we are getting minus 20 volts theoretically. But practically, the op amp will saturate at minus 0.9 of VCC. So let's start with the implementation. So for this subtractor circuit, at pin number 2, there is a resistance RF connected from pin number 2 to pin number 6. Then there is a resistance R1 connected from 2 to your input. So let us give the input, positive input over here. Negative of that will be grounded. Then at pin number 3, resistance RF is connected from 3 to ground and one R1 is connected from 3 to input. So let us give the input from here. Another supply. As we know that op amp can amplify AC and DC, here we are using the DC signal. So one input is connected at pin number 3. Ground. So this gives the input V2 and V1. Now we need to give the supply to the IC, plus 15 to pin number 7, minus 15 to pin number 4, and common to ground. This is very important. For IC 741, you require a dual supply, positive 15, negative 15 and a common. Positive 15 to pin number 7, negative 15 to pin number 4 and common to ground. Please remember this. Now we will set the inputs. So the equation is V2 minus V1. V2 is at pin number 3, that this is V2. So we'll set this to 4 volts and this is to your pin number 2. So we'll set this to 2 volts. So let's start. So V2 is 4 volts and V1 is 2 volts. So it should be 4 minus 2, 2 into 10. Approximately 20 volts should be the output voltage. So let us see what we are getting the output. Output is from pin number 6. So 1 at pin number 6 and negative is connected to ground. So if you see the output, it is 13.57. This is because the op-amp saturates at plus minus zero point 0.9 of VCC. So approximately 14.5 volts it will saturate. So the answer is the practical value will come out to be 13.57. Now let us change the voltages. Let us make V2 as 2 volts and V1 as 1 volts. So V2 is 2 and V1 is 1. So 2 minus 1 is 1. So 1 into 10. So approximately the answer should come out to be 10. Let us see. Again output at pin number 6 and other terminal grounded. So practically it is coming out to be 9.34. Theoretically it is 10. Practically it is 9.34. So the readings are matching. In this way, you can implement a subtractor circuit in the hardware. I hope this video was a little help for you. Thank you.